Hello everyone, here myself Rehan from BTech EPS third year at IIT Roorkee, and in this presentation I'm going to present my report for technical communication, that is PHN 319, and the topic for my report is comparative analysis of 8 and 16-bit microcontroller, and this whole report is made under the supervision of Professor Mayank at Physics Department at IIT Roorkee. Now this is the whole content of this video. First, I will introduce what the topic is. Then the comparison will be made on these following criterias. That is the CPU core, memory, clock signal and sources, peripherals. In the peripherals, timer and etc will be used, and then power saving modes and cost, and finally the conclusion. So, in today's world, embedded system can be found in nearly everything from noise cancelling a headphone to large aircrafts. In order to implement a embedded system, there are broadly three ways. That is, first is by using the general purpose processors. Second, by using application specific processor. Third, by using the single purpose computers. And for the general purpose processors, we use microprocessor, and for application specific, we use microcontrollers, and for single purpose, we use CPLDs. Now, application specific processors are widely used in the implementation of embedded systems. That is, the microcontroller are widely used, and in the market there are a lot of microcontroller present in today's world. So it is really a tedious task to decide which microcontroller should be used for our application. And the most and the this is the most time consuming part of the whole making of the final product. So the time to market is a crucial factor while developing a new product. A 4-week delay in delivering the complete product might result in 30% reduction in the revenue. So if we can reduce this time of deciding which microcontroller to use, then we can reduce the overall time to deliver the product, which could increase our profit. So this is what this report does. It makes a comparative analysis of these both microcontroller, and if someone goes through this report, then he or she can easily get an idea which to choose, and the overall time can be reduced. Now I have used 8 and 16-bit. For the 8-bit I have used Atmega 8, and for 16-bit I have used MSP 430 G2553 for comparison. Now, critical criteria on which one should look upon while choosing a microcontroller is the CPU core, clock signal, memory, peripherals, and power signal, and cost. Now, the CPU core, CPU is the brain of the computer. Its main function is to ensure correct program execution. On the basis of instruction set, CPU are of two types, RISC and CISC, that is reduced instruction set computer and complex instruction set computer. And on the basis of bus organization, there are two. One is the Harvard, and in the second one is the Von Neumann. For Von Neumann, there are different data and program bus, data and address bus, and for Von Neumann, they are single data and address bus, and for hardware, they are different data and address bus. And these are the CPU core comparison. The both are the RISC architecture. Atmega is hardware, and MSP is Von Neumann. Uh, in Atmega, there are 32 8-bit CPU registers, and in MSP 430, there are 16 16-bit registers. And Atmega 8 is 8-bit ALU, and MSP 430 is 16-bit ALU. Now, the software complexity for this architecture is more as compared to 6 because there are less number of instructions. So we have to repeat same task repeatedly in order to complete anything. And the parallelism is possible in Atmega 8 as it is based on Harvard. And MSP 430 have a constant generator which could increase the code size. If the data with which we are dealing with is mainly of the 8-bit only, then we should use Atmega 8. But if it's mainly 16-bit, then we should use MSP 430. Now, the memory comparison. In microcontroller, there are two types of memory. One is the program memory, and another one is the code memory. Code memory stores the data on which instruction to be executed, and the RAM is used for this. And in the program memory, instructions are stored, and the ROM is used for this. EEPROMs, as you can see, it is a type of ROM that can be reprogrammed electrically. The comparison is at Mega 8 have 8 KB of flash, it has 16 KB of flash. Flash is a type of ROM which is used to store program memories. And for RAM they are 1024 bytes, here 512 bytes. And for EEPROM, here it is 512 bytes. Here there is no EEPROM in no internal EEPROM present in MSP 430. Now factors to consider on: more the size of code, more the flash required, more the amount of variable used to store data, more data memory is required. If our system requires to store some value from sensor for future analysis, not to be lost our power cut, then EEPROM should be used. Now the clock signal and sources. Higher the frequency of clock, the faster is the code execution and power consumption will be more. Clock speed can be decided by intersample time of the sensor. So yellow line represent the intersample time. If the clock time should be more than this intersample time, then only it can detect the sensor values. Now, in any microcontroller, if we talk in a broad sense, then there are two types of clock signal. One is the external, one comes from the external crystal oscillator, and second one is from internal RC oscillators. There is a comparison of clock signal and sources at Mega 8 and MSP 430. Both external clock crystal in both can provide from zero point 0.4 to 16 megahertz, and the difference is in the startup time. That is, crystal oscillator takes some time to start and stabilize itself. So for at Mega 8 it is 35 millisecond, and from MSP 430 it is 100 milliseconds. An internal RC oscillator provides a fixed clock frequency of 1248 megahertz with an average startup time of 35 milliseconds. And for this MSP 430, it provides 1 to 16 megahertz and with an average startup time of 2 microseconds. So 2 microseconds is really a less time as compared to other time which we have seen for now. So this is a very distinct property of MSP 430, that is have only 2 microsecond of startup time for DCO. If now factors to consider on: if the environment is noisy or precise time measurement is required, then external cluster should be used. If there is variation in surrounding temperature, then RC oscillator should not be used. Startup time is another important factor to consider on. It is the time the cluster oscillator takes to turn on and stabilize itself. DCO is an essential feature in the MSP 430 family because of their very low startup time of 2 microseconds. Now peripherals. So peripherals assist the CPU in performing tasks and reducing the overall workload of the CPU. If we compare the peripherals, then we can see GPU, GPIO, ADC, timer, counter are common in both. Now, if we consider on the communication protocols, then LIN and IRDA are extra in MSP 430. And there is brownout protection here. That is, if voltage drop downs after a certain level, then the microcontroller goes in the reset mode. So in this report, I have compared ADC and timer of both microcontrollers because these two are extensively used peripherals. So timers are used for creating delays, baud rates, and counting events. Now, a dedicated hardware timer frees up the processor so it may focus on tasks that aren't time sensitive. So these are the comparison. So in Atmega, a 8-bit timers counter with separate pre-scaler one compare mode and no 8-bit timer present in MSP 430. One 16-bit timer counter with separate pre-scaler. Pre-scaler means we can change the clock frequency which we fed, like we can multiply it by some constant value 1248, and compare mode and capture mode with compare and capture mode. And in MSP 40 there are two 16-bit timer counter with compare and capture mode. Compare mode with we compare the timer value with certain value and our interrupt signal is generated. And in capture mode we took at certain instant of time we took the value what the counter is. Now factor to consider on: if we want more resolution in our PWM signal, then MSP 430 should be used as it is 16-bit timer. Now ADC is analog to digital converter. Mainly all types of sensor which we see are the analog in nature. That is, they provide a continuous value ranging from 0 to certain value. So but our microcontroller can only understand the digital value 0 and 1. That's why analog to digital converter is required. So this is the comparison of ADC of these two. In both 10-bit SAR, that is successive approximation register type of ADC is present. In SAR type of ADC, binary search algorithms are used in order to compare the external input signal with some predefined values. That is, zero point 0.5 volt can correspond to 0 to 1024 value, and 15 kspс conversion rate, and here is 200 ksps conversion rate, that is kilo sample per second. That per second how many samples it can detect. Now 6 external inputs can be used, and here 8 external input channels are there for ADC. Now, now factors to consider on KSPS value is decided on the basis of how frequent sensor value is changing. If it is low, then at omega it should be used. Otherwise, MSP430 should be used. In MSP430, DTC direct transfer controller is present, which allows the ADC 10 samples to be converted and stored anywhere in the memory without the CPU intervention. So this can reduce the overall time required for the code execution. Now, comparison of other peripherals. So one USR is present in both I2C. There is only one I2C. Now SPI, if we compare SPI, then at megabyte there is only one SPI module, but in MSP40 there are two SPI, and at megabyte there are 23 GPI opens, but MSP40 there are 24 GPI opens. Now the comparison of power saving modes and cost. So power saving mode is really important because in the power saving modes, all the modules are or the peripherals which are not required are turned off, on only the required one are turned on. So this can really save a lot of battery power or the power which we are drawing from some AC sockets and all those. So there are five power saving modes in at megabyte, and MSP40 there are six power saving mode as shown here. Now the wake up time for power saving mode is in milliseconds, but for MSP40 it is in microsecond. And the output current range is in milliamperes for at mega 8, and operating voltage is 5 volts. But for MSP430 it is in microamperes and operating voltage is 3.3 volts. The cost, if we consider the average cost by considering several websites, it's 300 Indian rupees, but for MSP430 it is 500 Indian rupees. MSC now factors to consider on MSC430 is well known for its ultra power saving modes, but its cost is high. Now this is the final conclusion of this report presentation. The number of devices available today are enormous. That is, there are a lot of and types of microcontroller present. As a result, choosing microcontroller is really a tedious task, but this microcontroller can assist you in doing so. All important deciding factors to choose a microcontroller is discussed in this report and presentation. One can get an overview of both microcontroller by reading this report and can reduce the time expend in the research to decide which microcontrollers should be used. So that's all from my side. Thank you.